welcome to this edition of Ask Klein Math. Today we're going to be taking a look at first grade TEKS 1.5D, 1.3B, and 1.3C, and we'll be focusing in on representing using objects and concrete models as well as pictures. As we begin today, I want to really lean into the use of manipulatives with these TEKS. And I'm going to start first with a problem right from our HMH resource, our Go Math book. And I'm going to do the multi-step problem. Asking students to go in at the highest rigor as they're solving these is really, really important. And so I want my students from the start to see that multi-step problems are not scary, and especially not when you can do them with manipulatives. So I'm going to lean into the multi-step problem today, as well as my tool, which is going to be my double 10 frame. So I'm going to put the problem here and then use the double 10 frame to help me solve, along with some counters. All right, so my problem says that there are 6 birds sitting in their nests. There are 2 turtles and 3 frogs swimming in the pond. And it asks me, how many animals are there? Well, this may seem a bit overwhelming, but if we take one bite-sized piece at a time and work one part at a time and start to put it together in our double 10 frames, I think our first graders will quickly see a solution. So I would ask my first grade students, what's the first thing that you know? What's the first thing we learned in the story? Well, we learned that there were 6 birds sitting in their nest. So I'm going to go ahead and put those 6 birds in my 10 frame. All right, that's taking care of that information. So then what else do we know? We know that there were 2 turtles and 3 frogs swimming in the pond. Well, we have to start with the first thing first, and that was the 2 turtles. So let's go ahead and put our turtles in. And I'm going to put my turtles in with a different color just to represent to my students that this is a different part of the story. Now, when we get to addition and subtraction, we may be putting these in to think about these, the other color as taking it away. But for this purpose, as I'm guiding them through this representation, I just want them to see that this is another part of the representation. So we had the 6 birds, we had the 2 turtles, and then what did we have left? We had 3 frogs. Again, I'm going to switch back to my red side on the counter so that they can clearly see the 3 frogs. And I'm not going to jump down to my next 10 frame until I have this one all filled up, which I filled up with 2 frogs, but my story problem told me there were 3. So I need to be sure that I don't skip and start filling in the other numbers down in this 10 frame. I want my students to see the representation of a complete 10 frame. That's very important, because then when I ask them how many animals are there, which is the question here, I don't want them to have to go back and count each one of those counters. I want my students to have the flexibility with numbers to see this 10 frame filled up and know that that represents 10. So then they can have 10 and one more counting on 10, 11, and they quickly can come up with the answer to that story problem. We just worked a multi-step story problem with these concrete objects, and it wasn't scary and it wasn't overwhelming to our students. We have to start small, and then we can build on the skills. The next thing I would like to show you to go along with these TEKS are some great little story match problems, which I also found in our HMH resource. There are 6 little cards that go along with this activity. And for my students in the room, this would be a fun scoot activity or a fun thing. I always love to put these on the cabinet walls and let them walk around with their notebook paper or their whiteboards and solve these. So for these, I'm going to solve them right on the table as I'm reading the problem. And again, I'm going to lean into my colored counters for that. All right, so this problem is asking me to, there's one big chair and 2 small chairs. So here's my one big chair, and here are my 2 small chairs. I'm going to see that that's 3. Now I'm going to tell my students as we start this activity that somewhere in this activity, there's a match for that. They just solved this problem, and somewhere there's another problem that's going to match that. It may not be in the same order, and it may not look the same when they model it, but the models are going to be equal when they finish. All right, then I'm going to move over to this one. There are 2 black socks and 4 white socks. Okay, I'm going to represent my 2 black socks, and then I'm going to represent my 4 white socks. Okay, these 2 models don't match each other. So I know that those are not the matches that I'm looking for. So I'm going to continue working. All right, there are 5 black butterflies and 2 white butterflies. So I'm going to lean in again. 5 black butterflies. And 2 white butterflies. All right. Does that match anything that I have so far? Nope, not yet. So I'm going to keep working. All right, this one says there are 3 white cats and 3 gray cats. So I have my 3 white cats and my 3 gray cats. I'm going to have to scoot these over a little bit for us to see. Or maybe I'll build my gray cats right underneath. Students could build the model in any way they would like to. All right, there's my 3 white cats and 3 gray cats. Well, let's see. Does that match anything that I have so far? Maybe, maybe not. Keep working. All right, there are 2 small trees and 1 big tree. So let's build our 2 small trees and 1 big tree. How many trees are there? And then this last one tells us that there are 4 blue boats and 3 yellow boats. So I'm going to build out my 4 blue boats. And my 3 yellow boats. Should have built my yellow boats with my yellow. We can do that. I can build out 4 blue boats. Switch those over. Let your students have the flexibility to change their mind as they're building their models. Nothing wrong with that at all. 4 blue boats and 3 yellow boats. All right, so now I'm going to look at these cards, look at these models that I've made, and I'm going to start to ask myself the question, is there a match? Is there somewhere that I can see that my total is the same, but maybe I have represented it in a different way? Well, the first one I would go with would be the smallest number because it's going to be the easiest for your students to see. So they're quickly going to see that with this problem, there are 3 counters. And with this problem, there are 3 counters. This is an opportunity to have the discussion about 1 red and 2 yellow being the same as 2 red and 1 yellow. As a matter of fact, I might even come down and build them underneath each other as I put these 2 questions together so that my students can see that first they said 1 chair and 2 small chairs. Here they said 2 small trees and 1 big tree. They're really the same kind of problem. They just moved the numbers around. This is the beginning of understanding the fact families in addition. So you want to be sure that you have the flexibility with that. Let them go ahead and work those together. And then when they make a match, they can take them off the table. So that leaves us with our socks, our butterflies, our cats, and our boats. So we start to take a look at these and see if we can find a match. Well, we may have to go back and count these counters. These are a lot of counters for them. You could build these in 10 frames if you would like to. 1, 2, 3, 4, 5, 6 counters here. Was there anywhere else that they saw 6? Well, there is, and it even helped him out with the answer there, and that was our 6 cats. We had 3 white and 3 black. So I would again put my counters here to show that these are equal. Even though the groups are represented differently in our problem, they are equal when we finish. And so students can begin to see that 6 can be made in different ways. Composing and decomposing numbers, 6 can be made in many different ways. Again, those are matches, so we can move them over, and then we'll double check our boats and our butterflies. So we can move our boats up by our butterflies and see, are we making the same number, just making it in a different way? And when we see that, yes, we are. So the first time we made 7, we used 5 and 2. The second time we made 7, we used 4 and 3. Both of those made 7. We just made 7 in different ways. Thanks for joining me for today's version of Ask Klein Math.